Well, hope you're completely fine and this pandemic situation has not affected you and your family much. So today I'm here to talk about light. Yes, the same way light we receive from the sun, but is the sunlight white in color? Well, let's see.
No doubt about it, I'm on fire. So you better come and get a little bit of more sunshine. You get it going, I'm on fire.
Since the time we were born until today, we've seen light in many different forms. Where a newborn baby is most likely to not see bright light, so he's likely to open his eyes in dim light or low light. But till today, we've seen many different forms of light. But the source of energy is sun. At the end of the day, all the forms of light we have seen are dependent on the sunlight. So the most fundamental form of light is sunlight. Some other forms of light are these artificial tube lights, bulbs, etc. But sunlight is the most fundamental and energy giving to the earth. Sunlight is white in color as we perceive it through our naked eyes, but there are secrets behind that white color, and they're really secrets. When you put a prism, this experiment was done by Sir Isaac Newton. He put a prism in the path of sunlight. The sunlight was coming in and he put a prism. Prism is nothing but a triangular glass. I won't say a glass slab because a glass slab is actually rectangular. A prism is a triangular glass of 5 surfaces. It's a kind of 3D triangle, you can say it. So he put it in the path of sunlight, and he observed that when sunlight crossed that prism, it was not white light on the other side. Instead, it was many different color of lights. It was vibrio. It was 7 different color: violet, indigo, blue, green, yellow, orange, and red. So that was the first time that we came to know that white light is not just white, but it is a composition of many different colors. Well, light is not just limited to its color or what we see. Just with the help of light, we get so much information. We get to know its wavelength, its frequency, its speed in a different medium. Well, if you are familiar with reflection, like when you see yourself in a mirror, you see your reflected image. Like reflection, there's also a phenomenon of refraction on which I've made a video. You can check it out. But telling about it in a nutshell, as you know, reflection is something in which light returns back to the medium. You see yourself in the mirror and you see your image. But refraction is something in which light does not return back at all or return back partially to the medium. Like you send light from air to water, some of the light gets absorbed in water. I wouldn't say absorbed, but it gets deviated in water, and some amount of light gets back in the medium, that is the air. This is why when you see yourself in the mirror, you're fairer. I wouldn't say fairer, like you can see a more colored image, but in water it is quite dimmer because of refraction and partial reflection. Each and every medium has different refractive index, due to which refraction is different in different medium. For example, in gas it is different in water. Diamond has got the highest refractive index, and etc. Refraction happens due to light, reflection happens due to light. But in a refraction, light shows many different colors, and different colors of light have got different characteristics while refraction. So let us see it one by one. I won't be taking each and every color, but I'll take the most important ones, that is violet and red. So first, talking about violet. Violet is the most sensitive out of the 7 colors you have read in the spectrum. it gets most deviated it gets deviated the most when it passes through any medium, be it a glass slab or a prism or any other medium. It gets deviated the most because its speed is less in a medium. When there is no medium, all these colors of light have the same speed. That is, in air and vacuum, all these colors of light have got the same speed bar. In air, there is hot air, cold air and normal air. And if you have seen fire, you would have seen that the image is quite diminished when you see from one side to the other. This is because the refractive index of hot air is different from that of normal air. This is the reason why you see a diminished image or not a clear image. Coming back to violet, violet has got the least speed in a medium. It has got the least wavelength but the highest frequency. This is why it gets deviated the most. What is that slip of the tongue? Yeah. Well, coming to red, red always wants to behave like boss. So it has got the highest speed in any medium, it's got the highest wavelength, but the lowest frequency. This is why it gets deviated the least, because if it's high speed, it crosses. Like, you might have noticed that when a person goes with a slow speed, he actually gets easily deviated. But when a car is going with a very high speed, it is very difficult to deviate that car. This is why red gets deviated the least in a medium. And this is why the angle of deviation of red is the least and that of violet is the most. And the colors in between have got different angles of deviation. So this is how the visible spectrum is arranged, in which violet has got the least wavelength and red has got the most, and vice versa for frequency. Talking about spectrum is not just limited to vapor. Like, it is not just violet, indigo, blue, green, orange and etc. Instead, it is a panel of light, like a whole bunch. I wouldn't say a bunch, it's not 12, but it is a lot of light, like gamma, X, ultraviolet, violet, infrared, and then I guess micro, and then radio. This is what spectrum is, but it is not the only spectrum. Instead, it is the electromagnetic spectrum. You cannot see the spectrum by passing light just on a normal prism. Instead, there are different forms through which you can detect different forms of light. Like, you are very familiar with X-rays. You go to, I think CAT scans, CITY, I don't know. You go for your X-rays, you get your skeleton on the X-ray, that black and white paper, or the paper which you get on which you can see your bones. That is actually because of X-ray light. X-rays are stopped by your bones, but they can go through your flesh. That's why X-rays are used for this purpose. Now I'll be taking up some of the most important parts of the electromagnetic spectrum. That is, I'll be taking up gamma radiations, X-rays, infrared and ultraviolet. So let's get going. Well, gamma radiations have got the least wavelength in the entire electromagnetic spectrum. Like, violet has got the least wavelength in the visible spectrum, which comes after ultraviolet rays. Yes, visible spectrum comes after ultraviolet rays in the entire electromagnetic spectrum. Like ultraviolet, and after ultraviolet it's violet, and after red it is infrared. So you can learn it that way, so you don't have to memorize it, it's just for your information. Coming back to gamma rays have got the least wavelength. I guess it is around 0.01 Newton meter, if I'm not wrong. It can cause biological damage to its most. That's why it is used in nuclear phenomena, not nuclear phenomena, but nuclear emissions. Like alpha, beta, gamma radiations are emitted, but they are radiations. Okay. Gamma rays can be stopped by a lead sheet. A sheet made up of lead can stop the gamma radiations, but that sheet needs to be thick. Gamma rays cannot be stopped by thin paper or thin cardboard. No, it cannot. So you require a thick lead sheet. So make sure to save yourself from World War III, or to just save yourself in World War III. You should keep lead sheets or lead coats in your house. Well, X-rays are important because of their medical importance. Like, you might have seen X-rays in the medical field. Well, I've already told you about that, so I'm not talking about that. But after gamma rays, X-rays have got the least wavelength, and X-rays helps us to get to know the structure of the complex molecules. So through X-rays you can actually get to know the structures on how the complex molecules are composed. Coming to the ultraviolet radiations, which comes just before the visible light in the electromagnetic spectrum. Well, ultraviolet is special. You cannot detect ultraviolet radiations by a normal prism. Instead, you need to go through a very different process. So for the detection purpose, silver chloride solution is used. So when you take silver chloride solution from the red end to the violet end of the visible spectrum, no change is seen, or no visible change is seen. But after you go beyond the violet radiations, you see that the brown colored silver chloride solution actually turns into blue black. And this is where we get to know that there are radiations beyond the violet end which are more energetic than the visible ones, and here comes the ultraviolet radiations. In order to get a spectrum of ultraviolet radiations, quartz prism is used. So you can get a spectrum of ultraviolet radiations using the quartz prism. Coming to the infrared radiations, in order to detect infrared radiations, a blackened bulb thermometer is used. You take the blackened bulb thermometer from the violet end to the red end, and after the red end, change is seen in the thermometer. Thus you get to know that there lies an energetic radiation after the red end of the spectrum, and there you get to know that infrared radiations are present. In order to get a spectrum of infrared radiations, rock salt prism is used. So this was all about light and spectrum. If you've got any particular recommendation on which you want me to make a video, drop it down in the comment section below. I'll surely check it out, and I read all your comments and I reply to all of them, and you know that. So if you've got any recommendation, you can drop it down in the comment. Till then, bye bye.